All right, number 6, we're going to find g of 0, g of -1, g of 4, and g of 1/4 using the given function. So 6, we are given g of x equals x divided by, and then we have square root of 1 minus x squared. All right, first we want to find g of 0. So part A, if we plug a 0 in everywhere we have an x, we would have 0 on top. Now, from right here, I already know that our answer is going to be 0. Only way it's undefined is if you have 0 on the bottom, but that won't be the case. So once you have 0 on top, 0 divided by anything will still be 0. But if we continue to solve, this will give us 0 divided by 1 minus 0 under the square root would be square root of 1. So you get 0 divided by 1, which is 0. So part A, we get 0. Now, part B, this time we want to find g of -1. So we plug a -1 on top, and then we have square root on the bottom, 1 minus -1 squared. So on the top we can't do anything, so we'll just break it out of the parentheses and write -1. On the bottom we will have the square root of 1 minus -1 squared is 1. So from here we have -1 over the square root of 0. So -1 divided by 0. So we cannot have 0 on the bottom. In this instant, the answer is undefined. There's no solution here. So we won't choose A. B is the one that says the answer does not exist, and that's going to be the better answer here. All right, part C. We're going to find g of 4. Here we plug a 4 on top, square root 1 minus 4 quantity squared would leave us with 4 over the square root of 1 minus 16 when you square 4, and then that would give us 4 over the square root of -15. Okay, so in this example where we can't evaluate negative under square roots, or they're imaginary numbers, so this one we got no solution, but this one is an imaginary solution, so we could simplify it, but it doesn't look like we are required to. If we look at the answer choices, answer choice C just says this is not a real number. Because of the negative under the square root, we would have an imaginary term. All right, and then the last part, D, we have a rational number to plug in, which just is something that can be put in fraction form. So we're going to do g of 1/4. G of 1/4. So we're going to plug a 1/4 on top, and on the bottom we're going to have square root of 1 minus 1/4 quantity squared. All right, simplifying, 1/4 on top. When you square a fraction, you square top and bottom, so we have square root of 1 minus 1/16. All right, so working in the bottom, in order to combine like terms, we have to have a common denominator. So instead of writing this as 1, I'm going to write it as 16 divided by 16 because that is equal to 1, and it will also allow me to simplify this minus 1 over 16. So we have 1 over 4, and then we have square root, and this is going to be 16 over 16 minus 1 over 16. All right, so from here, I'm going to wrap around, start back on this line. So I have 1/4 on the top. On the bottom, I have square root, and this is going to be 16 minus 1 is going to be 15, and then the bottom stays the same, so 15 over 16. All of this is still under the square root. So you can evaluate the square root of a fraction by taking the square root of the top and the bottom. Okay. So I have 1 over 4, and this is the same thing as saying the square root of 15 divided by the square root of 16. The reason why we want to separate it is because we can evaluate the square root of 16. This will give us 1 over 4 divided by the square root of 15 over 4. So when you have the same or a fraction divided by a fraction, there's no such thing. We're going to do keep, change, flip. So that means we're going to keep what's on the top, 1/4. Change the division to multiplication, keep, change, and then flip the bottom fraction. So this will be 4 over 15. Now we will multiply straight across, or we can reduce before we multiply, top to bottom or top to bottom diagonally. And since we have a 4 on the top and the 4 on the bottom being multiplied, we can reduce those. I lost my square root here. So we would end up with 1 over the square root of 15. Now at this stage you would want to rationalize the denominator, but the computer will accept this answer, and this is okay. However, if you rationalize the denominator and you multiply top and bottom by the square root of 15, you would get square root of 15 over 15. And either one of these answers is acceptable. This one is better. This one is, just good enough, but if possible, you want to rationalize. So I'm going to type the unrationalized solution just to show you that it will accept it. But either one, this second one is better. 1 divided by the square root of 15.